Hello everyone, I am Gagan Laddha and today we are going to study about gyroscope, or rather I should call it as gyroscopic effect. Gyroscope is just a device which works on the principle of gyroscopic effect. In this particular lecture we are going to study what actually is gyroscopic effect. Now before starting this lecture I am going to show you something. We have a very special guest with us today and he is going to show you something. Now what is he doing? He has a wheel, and if he is holding this wheel from one end and releasing from the other, it will fall down as expected because of gravitational force. But what if he is spinning this wheel? If he is spinning this wheel, surprisingly this wheel does not fall down. This is defying gravitational principle. So what is this? This is because of gyroscopic effect, and that gyroscopic effect which we are going to study today. Now let us understand what actually is this gyroscopic effect. So let's suppose we are having any rotor which is rotating about an axis. Let's suppose x-axis. This is the coordinate system we are having, x, y and z axis, and we are having this rotor. This rotor is rotating clockwise when seen from the origin. जब origin से देख रहे हैं, then this is rotating as in clockwise direction along x-axis. Okay, now what we are doing, we are turning this x-axis, this ox axis around y-axis. We are turning this ox axis about y-axis. So when we are turning this, the final position of this ox axis becomes this ox dash, and this will be our rotor. Okay, just remember this thing, this is the horizontal plane. Okay, this is moving in an horizontal plane. This is the xyz coordinate. Okay, and we are turning this in this plane, in horizontal plane, in xz plane. Getting this or not? Now what will happen, because of this change in direction, there will be change in angular velocity, and because of the change in angular velocity, an angular acceleration will develop. This angular acceleration will develop around the perpendicular axis, that is the third perpendicular axis, that is the z axis. And because of this angular acceleration, a torque will be developed. That torque is nothing but a gyroscopic torque. And because of the gyroscopic torque, a reactive gyroscopic torque or a reactive gyroscopic couple will develop. And this reactive gyroscopic couple causes gyroscopic effect. I will make this more simpler. Now, let us first consider, we are considering this rotor rotating about x-axis. Just understand this thing very carefully. Okay. Now what will be the direction of angular velocity? So in order to get in order to make the angular velocity vector, three things are necessary to make a vector. First thing is magnitude of the vector. Second thing is direction of the vector. And third thing is sense of the vector. So we have to draw the angular velocity vector of this rotor. Okay. Now what is the magnitude of the vector? Magnitude we can determine, v is equal to omega into r, magnitude we can determine. What will be the direction of the vector? Direction will be along this direction about which this rotor is rotating. This rotor is rotating about x-axis, so this will be the direction of the vector. And in order to determine the sense, we will use right hand screw rule. Okay. Now what does right hand screw rule says? This rotor is rotating in clockwise direction when seen from the origin. Okay. Now what I have to do, I have to take this right hand and I have to curl my finger in the direction of rotation of the rotor. Okay. That means I am curling this fingers in a clockwise direction. Then the direction in which this thumb is pointing will give me the sense of that vector. Getting this or not? So we have the magnitude, we have the direction which is along this x-axis, and we have the sense along this direction. If this is rotating clockwise, if this is rotating anti-clockwise, then I have to curl this in an anti-clockwise direction, and this will give me the sense. Getting this? So I have the sense, I have the magnitude, I have the direction, so I can plot the angular velocity vector. Let that angular velocity vector be OA. Okay. And the distance of this vector, the length of this vector will give me the magnitude of that angular velocity. First thing. Now what I am doing now is I am turning this axis about y axis. I am turning this OX axis about y axis, and final position becomes OX dash. Okay, so final velocity vector will be like this. Let's suppose OB is the final velocity vector. Now what will happen if the angular velocity remains same as omega, then also there is change in direction, and because of change in direction there will be an angular acceleration, and that angular acceleration will act along the third perpendicular axis, that is along the z axis. Okay, so there will be an angular acceleration acting because of change in direction of angular velocity. Now whenever there is angular acceleration alpha, and if this is having some mass, the rotor is having some certain mass and it is having some angular acceleration, this means a torque will develop. And how can we determine the direction of the torque? Same with the right hand rule, the direction of angular velocity, the direction of angular acceleration will be same as that of the direction of change in angular velocity. The sense of the angular acceleration will be same as that of the sense of the change in angular velocity. That means the sense will be same. The direction of torque will be in the direction of this curled finger like this. Okay, so direction will be like this, in the direction of curled finger. Okay, so this is nothing but an active gyroscopic couple. Now a reactive gyroscopic couple act in just opposite direction. Just opposite direction means the reactive angular acceleration will be like this, b dash a dash, and because of this a reactive gyroscopic couple will act Okay. Now what is the role of this reactive gyroscopic couple? This reactive gyroscopic couple is acting in upward direction. This reactive gyroscopic couple will try to move this in upward direction like this. This is reactive gyroscopic couple. Now we were explaining that balancing phenomena, that how can that wheel be balanced. Now how can the wheel be balanced now? So if the weight is acting downward here at certain length, okay, that means a torque is developed. Suppose that length is small x, then the total torque developed is nothing but W into small x. Okay, so when the reactive gyroscopic couple becomes equal to this torque, then this weight will be balanced in a horizontal position. So I will show you now with the help of a 3D animation. Let's suppose we have this wheel which is hanging from a string and I am holding it from one end. If I release this, it will fall down under gravity as expected. But what if I am rotating this about this axis and I am rotating this axis about another axis? This will be balanced. This is because of gyroscopic effect. And how can this be explained? Just look at here. So this wheel is moving in this direction, in this plane. So angular acceleration will be in this direction like this. This is the direction of angular acceleration. The active gyroscopic torque will act in this direction. For reactive gyroscopic torque, this will be inverse. So reactive gyroscopic torque will act in just opposite direction. So what actually is happening? Because of the weight of the wheel, a torque is acting in downward direction, which will try to pull this downward because of gravitational force. A reactive gyroscopic torque is acting in opposite direction, which will try to balance that wheel. So this is nothing but a gyroscopic effect. Getting this or not? Now let us determine the magnitude of that gyroscopic torque or gyroscopic couple. Now let this OA be the angular velocity when axis is OX. Okay, when the axis is OX, the angular velocity is OA. OB be the angular velocity when axis is OX dash. Okay, AB will be change in angular velocity. Why is this angular velocity changing? Because of the change of axis of spin. Axis of spin is changing from OX to OX dash, therefore the angular velocity is changing. So AB is nothing but change in angular velocity. And what will be this change in angular velocity? Suppose this is turning by an angle d theta. Okay, so what will be the change in angular velocity? This is nothing but omega into del theta. Omega into del theta. This is change in angular velocity. Now, what will be angular acceleration? The change in angular velocity per unit time. So, this angular acceleration will be equal to omega into del theta by del t. For limit del t tends to 0, this angular acceleration alpha will be equal to omega into d theta by dt. So, this is change in angular acceleration, omega into d theta by dt. Now, what actually is this d theta by dt? D theta is the angle turned by this axis about y axis. Okay. So, this d theta by dt is nothing but angular velocity of axis of spin. Okay, there are two different things. First thing, the omega. What is this omega? This omega is the angular velocity of a spin, the angular velocity with which this rotor is spinning. Second thing, the axis in which this rotor is spinning, that axis is also moving by an amount d theta. So, d theta by dt is nothing but angular velocity of axis of a spin, and this is also called as angular velocity of precision. This is angular velocity of precision. And here this OY axis is nothing but the axis of precision about which the axis of a spin is rotating. That is the axis of precision. So, this is also called as omega p. Getting this or not? Okay, so from here this alpha will be equal to omega into omega p, omega into d theta by dt. Getting this? And because of this angular acceleration, a torque will be acting. That torque is nothing but the active gyroscopic torque. And what is the magnitude of the torque? This torque is nothing but I into alpha, where I is mass moment of inertia. Okay, so from here we can get the value of this torque. This torque is equal to I into omega p. This is nothing but the active gyroscopic torque or active gyroscopic couple, and because of this couple, same magnitude of reactive gyroscopic couple will also act. Okay, so this is actually the magnitude of this gyroscopic couple. Okay, and the direction we have already seen. The direction in which the angular acceleration is acting, opposite will be the direction of the reaction. Okay, and the effect of this reactive gyroscopic couple is nothing but a gyroscopic effect. Getting this or not? Okay, students. So when you have understood this, now we will see the effect of gyroscopic couple on aeroplane. So what happens when an aeroplane is taking a turn? Let's suppose this is an aeroplane. This is the top view of the plane, and this is the front view of the plane. Okay, and now suppose this rotor, this is the rotor which is turning in a clockwise direction when seen from the rear end. When we are seeing from the rear end, this rotor is rotating in a clockwise direction. Now what happens when this is taking a left turn? This is the top view. So when this aeroplane is taking a left turn, then what will happen? Let us analyze this thing. So initially, what will be the angular velocity vector? So in order to have the sense of that angular velocity vector, since the rotor is turning in a clockwise direction, okay, so the sense will be in this direction. Okay, so this will be along the axis of the rotor, and the sense is along this direction. Now what if this aeroplane is taking a left turn? So if this aeroplane is taking a left turn, this rotor will turn left. Okay, so what will be the final angular velocity vector? It will be like this, OB. Getting this or not? Okay, so change in angular velocity or angular acceleration is AB. Okay, so what will be the direction of the active gyroscopic torque? It will be like this. And what will be the direction of reactive gyroscopic torque? It will be in opposite direction. Getting this or not? This means, what does this mean? This nose will rise because the reactive gyroscopic torque is acting in this direction. Okay, so when the aeroplane is taking left turn, it will rise the nose and lower the tail. I will explain you again. This is the angular velocity vector initially. After taking the turn, the angular velocity vector becomes OB. So this AB is the change in angular velocity or angular acceleration. Okay, so the active gyroscopic couple will act like this in the direction of the curled finger, like this in this plane. So the reactive gyroscopic couple will act like this. So it will raise this nose and lower this tail. Okay, so if the aeroplane is taking a left turn and if the rotor is rotating in clockwise direction when seen from the rear end, then the nose will raise and the tail will lower. Getting this now? Okay, and vice versa. If the aeroplane is taking right turn, so what if this is taking a right turn? The initial angular velocity vector is OA, the final angular velocity vector will be OB. Okay, so this will be the angular acceleration. This will be the reactive gyroscopic couple. Okay, so this will lower this nose and raise this tail when this is taking a right turn. Okay, so when the aeroplane is, if I summarize this, when the aeroplane is taking a left turn and this rotor is rotating in a clockwise direction, then the nose will raise and tail will lower down. Okay, and if either the direction of the rotor is changing or the direction of plane is changing, it will inverse the effect. And if both are changing, that means if the rotor is rotating in anti-clockwise direction and plane is turning right side, then we will get the same effect. That means this nose will raise and the tail will lower. Okay, so let us now analyze the effect of gyroscopic couple on this aeroplane. So let's suppose this aeroplane is, the rotor of this aeroplane is rotating in a clockwise direction. When this aeroplane is taking a left turn, the angular velocity will, angular acceleration will point in this direction. The active gyroscopic couple will act in the direction of the fingers curled. The reactive gyroscopic couple will act in opposite direction. So because of this reactive gyroscopic couple, the nose of this aeroplane will rise and the tail will lower. So this is the effect of gyroscopic couple on turning of aeroplanes. Now, what is the effect of this gyroscopic couple on a naval ship? So we have this naval ship. This is the top view of the ship, and this is the side view of the ship. Okay, the fore end is called as bow. These are few terminologies of the ship. Fore end is called as bow. Back end is called as stern or aft. Left side is called as port, and right side is called as starboard. Okay, this is the longitudinal axis and this is the transverse axis. Now, three different phenomena may occur in the ship, and we will analyze the effect of gyroscopic couple in all these three different phenomena. The first phenomena is the steering. Now, what is the meaning of steering? Steering means just moving left and right. As we know the steering in car, what is the function of the steering? Just moving left and right. Okay, so if we view from the top, this phenomena is nothing but steering. Moving left and moving right. Okay, so what will happen if the ship is moving in left direction, and what will happen if the ship is moving in right direction? Okay, so let us analyze this thing, and this phenomena will be same as that we have studied in aeroplane. Okay, so initially this is our rotor. Suppose that rotor is rotating in a clockwise direction. So because the rotor is rotating in a clockwise direction, the direction of angular acceleration will be like this. This is OA vector. Initially the angular acceleration, angular velocity, okay. When this is turning left, suppose this is turning left, the final angular velocity vector will be OB. Okay, this will be the angular acceleration vector AB. This is active gyroscopic couple in this direction. This will be reactive gyroscopic couple in opposite direction. Okay, so what is the effect of this reactive gyroscopic couple? This will raise this bow and lower this stern. So if the rotor is moving in a clockwise direction when seen from the rear end, and if ship is taking a left turn, then this bow will raise and stern will lower. Okay, if the rotor is rotating in an anti-clockwise direction, or the ship is suppose the ship is moving in right side, so what will happen when the ship is turning right? The rotor is rotating in same clockwise direction. Then what will happen? This is the reactive gyroscopic couple, like this. Okay, so this will lower this bow and raise this stern. Getting the phenomena or not? Very simple to understand. Okay, so this is the effect of steering. Okay, now next phenomena is the pitching. Now what will happen in a pitching? What actually is the pitching? Pitching means moving up and down along this transverse axis. This transverse axis के about जब up down होती है ship, then that is known as pitching, like this. Suppose this is the ship, this is the transverse axis, it will move like this. This is pitching. Okay, and this we can see from the side view. Okay, so this will move, suppose by an angle theta, like this. Heading is not. So this phenomena is known as pitching. Now, okay. Now, if the ship is pitching, let's suppose that pitching motion be a simple harmonic motion. Let's suppose the pitching motion be a simple harmonic motion. Okay. So what will be the value of this theta? This theta will be equal to, this will be equal to phi sine of omega 1t. Okay, where phi is the amplitude, theta is the displacement in vertical plane. The displacement in vertical plane is theta. Phi is the amplitude. Amplitude means the maximum angle to which this is turning. The maximum value, the maximum angle to which this is turning is nothing but phi. Okay, this omega 1 is nothing but the angular velocity. T is the time. Okay, so this theta will be equal to phi sine of omega 1 t. Now, how can we determine this, the value of omega 1? This omega 1 will be equal to 2 pi by Tp. Okay, where Tp is the time period of simple harmonic motion. Now, what will be the angular velocity of precision? What we call as omega p. What will be the angular velocity of precision? So what will be this omega p? This omega p is nothing but d theta by dt, as we all know. Okay, or you can say d by dt of theta is nothing but phi sine of omega 1 t. Okay, or you will get d by dt of phi sine of omega 1 t. So this will be equal to phi into omega 1 cos of omega 1 t. Heading is not. Okay, now what will be the maximum value of this omega p? What will be this omega p? Omega p will be maximum when this cos of omega 1 t is equal to 1. Okay, so this omega p maximum will be equal to phi into omega 1 for cos omega 1 t is equal to 1. So this is the maximum value of omega p. Okay, so what will be the maximum gyroscopic couple? What will be the maximum gyroscopic couple now? So this maximum gyroscopic couple T will be equal to I into omega p max. That's it. So this is the magnitude of maximum gyroscopic couple. Okay, and effect I have already told you, if this is pitching upwards, then this will move towards starboard, and if this is pitching downwards, this will move towards port. Okay, so this is the effect of pitching on a naval ship. The third phenomena is rolling. Now, what is the effect of this rolling on the naval ship? The effect of gyroscopic couple during rolling on naval ship. Okay, what actually is the rolling? Rolling means about this longitudinal axis, this is moving like this. Suppose this is the ship and this is turning about the longitudinal axis like this. This phenomena is called as rolling. This phenomena is called as pitching, turning about transverse axis. Okay, and just turning left and right is nothing but steering, as we have already seen. So what if the ship is rolling, then what is the effect of the gyroscopic couple? Let us analyze this thing. Okay, so we have this axis of spin as this axis, longitudinal axis is nothing but the axis of spin. Okay, secondly, the axis of precision is also the same axis. So because axis of precision is always parallel to that of axis of spin, so there will be no gyroscopic effect, no effect of the gyroscopic couple during rolling. Getting this or not? Okay, so these are the different effects of steering, pitching and rolling in a naval ships. Okay, let us solve one question. This question was asked in GATE 2016. A car is moving on a curved horizontal road of radius 100 meter with a speed of 20 meter per second. The rotating mass of engine have an angular speed of 100 radian per second in clockwise direction when viewed from the front of the car. The combined moment of inertia of rotating mass is 10 kg meter square. The magnitude of gyroscopic moment is. Okay. So, the radius in which the car is turning is given as 100 meter. The speed of the car is given as 20 meter per second. Okay. And angular speed of the engine is given as 100 radian per second in clockwise direction when seen from the front. Okay. The combined moment of inertia I is given as 10 kg meter square. We have to determine the magnitude of gyroscopic couple. Okay, so as we know, what is the magnitude of gyroscopic couple? T is equal to what? I into omega p. Now we have the value of this I, mass moment of inertia. We have the value of this omega, that is the angular speed of rotation of the engine, which is given as 100 radian per second. The only thing we have to determine is this omega p. That means angular velocity of precision. Now, how can you determine the angular velocity of precision? So this is the car, this is turning, taking a curved path, and the radius is 100 meter. The radius of that curvature is 100 meter. Okay, so what will be the angular velocity? Angular velocity of precision. So this omega p is nothing but v by r. V is equal to omega into r. So this will be equal to v is given as 20 divided by r is given as 100 meter. So this will be equal to 0.2 radian per second. Okay, so just put the values. So this gyroscopic moment will be equal to 10 into 100 into 0.2. So this T will be equal to 200 Newton meter. Answer. Very simple question.